All right, let's go ahead and talk about calorimetry and how we can use calorimetry to calculate the energy change within a system. And so calorimetry is an experimental technique that is used to measure the change in energy of a chemical reaction or a phase change. And so you can do either of them, and we'll talk more about chemical reactions and energy change in the future. But essentially what you do is you put a chemical reaction or phase change in contact with a water bath. And a lot of times you have it somehow within the water bath itself. And in your notes you can see there's actually an example of the setup of that. And essentially what happens is when it's in the water bath, the chemical reaction or phase change will either give off heat or absorb heat, and it will go into or from the water. Now, what we do is we measure the change in temperature of the water. So again, we have a chemical reaction occurring within some sort of volume of water. We measure the temperature change of that water. And because we know that energy can't be created or destroyed, whatever amount of energy the water is absorbing is going to be equal to the energy that the reaction gives off. And so the energy change in the heat bath will be the same amount of energy as the chemical reaction or phase change. It's just that it's going to have an opposite sign, because if the water is absorbing energy, which is a positive Q, that means the reaction is giving off energy, which is a negative Q. Because again, if it's absorbing energy, the other one must be losing. And then vice versa, if the water is losing energy, it's because the reaction's absorbing that energy. And the assumption behind the calorimetry is that the energy gained or lost by the water is equal to the energy lost or gained by the object that we're studying. So whether that be a chemical reaction or just some sort of phase change. Now, something that we want to keep in mind is that the specific heat of water is 4.18, and so that is the that is going to be very important because we're going to use that number a lot. Also, a common calorimetry that we use, or calorimeter that we use, is a coffee cup calorimeter. And essentially, if you think about those little styrofoam coffee cups, those are pretty good insulators, and so they're really useful in this, sort of lab setting, in a high school chemistry lab, because they are pretty good insulators. And so they're gonna resist the change in temperature with the surroundings. And so if you think about this, we have this styrofoam cup, we have some sort of chemical reaction happening on the inside of it, and we also cover the cup so that we don't lose that much heat. And then what ends up happening is the water will either gain heat or lose heat based off of if the reaction is absorbing heat or releasing heat. Now, in the real world, they don't use coffee cup calorimeters. Instead, they have more sophisticated, better insulated calorimeters. Particularly a bomb calorimeter provides a great insulation and reduces heat loss to the surroundings. And so in the real world, they don't really use coffee cups, they use other fancier stuff. And that's it when it comes to calorimetry. Go ahead and watch your guided practice problems, and we will go over some of those types of problems.